All right, welcome to another basic post-processing class. When we left off Wednesday for office hours, we had been working with some comment strings and had developed some code to save the operation comment so that we could separate it from the manual entry and move that comment output where we want it. At the end of class, we're having some issues trying to figure out where that output was coming from. Of course, as soon as I got off of the broadcast, I just went and did a couple quick checks. I ran it through the debugger and I figured out where my issue was. It was where we were trying to output the saved comment. That was actually part of an if condition. So there's an if condition that has a set of brackets that groups a whole bunch of conditions together, and I was just putting my output in the wrong place. So what it did show me, though, is that it's this is actually a great example file for us to use to run through the debugger, because the debugger will help show you very clearly how the code is structured and what is being called when. So that's what we're going to start with tonight. We're going to do an overview of the debugger. After that, we're going to start talking about numeric variables, but let's see how far we get with the debugging. Depending on questions and that sort of thing, it may end up taking us most of the night because it's a fairly involved subject. So first things for the debugger. There are a couple different ways to debug a post processor. In the old days, before the debugger utility, the only way to debug code output was to add things like string literals to your post and then run the post processor and review the text output. There are some variables that were part of that posting process, and some of them, but not all of them, are now obsolete. So if you look at the top of most modern posts, included in that is MP master. This one happens to be an MPL master, I believe, is what we're basing this post on. Oh, you know what I did, guys? Because the control definition had been updated, I actually accidentally overwrote that post. So there's a good lesson. When you're working on a post like this, make sure you make backups, because I didn't end up backing up the edited version of that post. So we'll get to make those changes again. That's okay. Let's see. We'll get it. So if we look up at the top of the post processor, when you look at one of the generic Fanuc post processors from CNC Software, or you look at MP Master or MPL Master, they will have different command and configuration variables set. If we go look at the generic Fanuc 4X MT lathe post, go to public documents, shared MCAM 2017, lathe, posts, and we look for generic Fanuc 4X MT lathe. Once you get past the post comments, you'll see a section that looks something like this. Debugging and factory set program switches. The first thing we define are some constant variables. Constant meaning the value is going to stay the same and not change. By the way, one of the things I do with the Mastercam Code Expert Editor, if you go to the File menu and you go to Options and then Document Settings, there are a couple options on here that I think are pretty important. Auto convert tabs to spaces is something that you definitely want to turn on. The MPDLL does not recognize the tab character as being equivalent to a space. So what ends up happening is you can have tabs in your text editor that push the line of code over to the right, but when MP parses it, it does not see that data as being offset from the first column. The other thing that I'll sometimes turn on is the white space checkbox. And the white space checkbox actually, for every space character, will put a little blue dot in the center to indicate that it's a space. And I'll do this as I am working on indenting nested post blocks. So anytime you're working with if-else conditions and you need to nest those results, you generally want to use bracketed post blocks, and we'll talk about that. For document settings here, if you go to default text and then tabs, I like to set it to 2, and I do that for MP. So under the MP language for tabs, I have it set to 2, and NC tabs, set it to 2. And what that means is that every time I'm going to create a new line and I hit the tab key, Mastercam Code Expert Editor inserts 2 spaces for every press of the tab key. If I don't have auto convert tabs to spaces turned on, then when I hit the tab key, it inserts that number of spaces, whether it's 2 or 4 or 6, but the MPDLL doesn't recognize these tab characters as spaces. So be careful with that. So a lot of times I'll turn on show white space just so I can see my indenting and make sure that there are actual spaces and not tab characters. So we'll turn off the white space display. This is the top of the generic Fanuc 4X MT lathe post. And factory set program switches in a lot of cases have to do with these variables here. These variables are control variables or command variables. They are used to set options for MPDLL. Basically, they tell MPDLL how to process different sections of the data and set kind of global settings for the post processor. Skip lead flags, so do not use V9 style contour flags. SX support MC. Use this to enable the new pick-off cutoff functionality. This is a lathe specific function. Rapid type V7. Tool change aft. This switch is pretty important. This has to do with tool change processing, and most modern posts are going to have this set to 1 or 2. If you don't have this switch set, it can influence the way that MP processes the tool changes. What tool change after does is it tells MP to automatically read ahead one move after the tool change to get the first rapid move position. And the reason it does that is so we can calculate some contour flags. We can do some calculations in the background. So most modern posts, you definitely want to have this. You'll notice that this post still has a reference to bug 4. Somebody's telling me I left auto convert tabs to spaces unchecked, and I did. So thank you. That's a good point. Thank you. If we look at MP Master actually has a reference for bug 1, bug 2, bug 3, but you notice that the upgrade utility, while it was parsing this post processor, actually automatically took this variable out. So you see CNC, pound CNC, fail, bug 3. While we were updating this post processor, the update post utility saw this variable, noted that it was no longer supported, and actually automatically removed it from the post. Bug 1 and bug 2 are essentially obsolete as well. These were used before we had the debugging utility. And what we could do is, while we were processing NC data, we could have the post processor write the names of the post block labels to the right hand side of our NC data for where the output occurred from. It was kind of a clunky method, but it was really all we had in order for us to output debugging data. Nowadays, the debugger utility supersedes that. The only one that's really still valid that we use anymore is bug number 4. So this variable, bug 4, controls the output of variables when we're using the tilde. So the tilde character looks like this. If I hold down Shift, it's the button just above the tab key. Looks like a little sine wave. That character, when placed in front of a variable name as part of an output statement, tells MP to output the current value of the variable without changing the modality or the state of the variable at all. So we can actually use the tilde character in front of a variable name to debug it. And when we use the tilde character, the setting for bug number 4, the value, will change the output. So a value greater than 0 applies the variable formatting with the debug output. So it will actually output the formatted value of your variable. A negative value will output the raw value. So it says 0, but I think it's actually negative. So if you make it -1, for example, it will output the value with no rounding applied. So bug number 4 is generally the only one we still use. Sometimes you'll see, like in this post, we've got bug 1 and bug 2, but we don't write this data to the right side of the text anymore. So there's because it relied on bug number 3. So even though bug number 3 is obsolete, it still allows us to use bug 1 or bug 2. We do also need to set fast mode to no. So if you have the fast mode variable in your post and you're using bug number 4, then you want to make sure you set that to no. We'll look at that a little bit when we do some debugging output from the post. But for now, let's take a look at running this through the actual debugger. We did have some test code that we were looking at. Let's go ahead and add that back since I got rid of it. So we're going to come down through the post here, past the string selects, and it was over by the comments. No. When you look through most modern post processors, there's kind of a general organization to them. They tend to group things together. So for example, I'm looking at a section that is string select tables. Okay, so here is one string select table. You notice it says generate string for spindle, comma, mill. Here's another string select table, tail stock M code selection. Here's another set. This one actually is just a set of variables. It's not part of a string select table. As you look at these, there will be another section where we just, in general, initialize variables. So here's buffer stuff, here's more buffer stuff, and here's just kind of general initialized variables. Some of these you do want to keep in order. Any of these where they say vector or matrix, here's a mapping matrix, here's another matrix. All of these, the order of the list of numbers here or variable names matters. You want to keep them in order. As we're jumping around, so scrolling to the top, scrolling to the bottom, the old way, or still is a way, but the old way of kind of jumping from place to place was to set a bookmark. So if, like, I'm on line 638, if I right click bookmarks, toggle bookmark, puts this little icon to the left here. To jump between bookmarks, create another one here. You can see that the shortcut on the keyboard is Control-Shift plus or Control-Shift minus to jump between them. Starting in, I want to say X9, it's either X9 or 2017, the Code Expert Editor has been enhanced to support comments that allow you to do code folding. And it's basically a way for you to designate the start and end of a block of code that you can then collapse. So for example, this is all of the numeric variable initializations, common user defined initializations. I'm going to start, and I like to use these little comment block areas as the place where I build my region. So these code folding areas are called regions, and they start with a pound sign and then the word region in all caps. When you type in pound region, you'll notice that it starts this basically bracket section. So it's got a little minus sign next to it and this vertical gray bar. And the only thing you can have to the right of pound region is a comment. And that's why I put this region right in the middle of these two lines of dashes, these two comments here. So common user-defined variable initializations. And I'm going to go down till I kind of find that next section. And that's going to look like this. Here's buffer definitions. So just above buffer definitions, I'll start in the first column with pound end region. And so what that gives me is a grouping of code that I can then collapse. So everything here from that starts with common user defined variable initializations, I can click the minus sign and I can collapse that section of code. So we'll do this. Here's the buffer definition stuff. So we'll go past that. There's the end of the buffers. And this really makes scrolling, up and down through the post a lot easier. This one's string and string selectors. So, pound region. We'll go to the bottom of the strings and string select tables. That's really here. I guess we could put the tables in there too. That's fine. Now you can also group subregions within a region. So for example, this is string and string selectors. There's error messages. All the rest of this stuff down below here is string select tables. So I'll do this. I'll make this its own region. General GNM code string select tables. Okay, and now just the string select tables we can collapse. So come up here to this minus sign, so we can collapse that. And so you can really kind of very nicely organize your post. Oh, and I guess the region end region doesn't need to be in caps. It can be lowercase as well. So if I do a replace, yeah, so you can do it with lowercase as well. Okay, so we had some code that was in the comment. And we created a variable. We were messing with G code 1008, which is the operation comment. And we created a bracketed post block. So if G code equals 1008, we can now break up the output in here. We were going to say if SOF flag equals 0. So if we're still processing the start of file, SOPCOM equals SCOM. Save operation comment. Now, in this case, when this is true, I actually want to have two actions take place. I want to save this variable. I also want to reset the flag variable. So I'm going to nest another set of brackets, one open, one close, square bracket, and we'll set SOF flag equal to 1. Now, currently, this will only capture one line for the operation comment. If you want to use multi-line, we're going to have to add some extra code to that. But for now, we'll leave it as is. We are going to put the else condition here. So we need this variable to be initialized before we can use it. And if we go look at the pheader custom here, what we're going to do is we're going to take this comment $, and we're going to move it. So what I'll typically do is put a £sign in front, which is called commenting out the code that was already there. And I'll go put this at the end of pheader. So we're going to dump all the comments at that point. When we get into processing the comments, it's actually going to reset that header variable for us, so we won't need to worry about it there. Now, we've got SOP_COM with the saved variable name, and the place where I wasn't seeing what was going on here, if I look at this condition, if not sync flag and toolop equals 67, and I put my cursor here, you can see it might be a little, we'll blow it up a little bit. The background is gray for this little bracket right here, and the line itself has like a light blue background. The matching close bracket for this open bracket is down here. So this if condition controls all of this code output. Whether it's output or not, it's within these two brackets. Then we have another if condition, and this is what I missed before. One of the things that's important to do with this code is to always be very neat and organized when you write it, and to indent consistently, because it'll help you from missing something like I missed something when we were in class. So what I'll do here as well, I'm going to go in and turn on show the white space. Standard indenting in a Mastercam post is 6 spaces. 1, 2, 3, 4, 5, 6. So down here after this comment, this here should be 6 spaces. Right now I think it's 8. And when we have the comma for a condition, so if not, then the comma, we want to indent everything below it 2 spaces. So this is correct, this is correct. We have another if condition, so we indent 2 spaces. That's good. Here we've got an if condition. So if tool sequence number is 2, $n equals $t. Now I think what we had here, we have the tool comment line coming out, which is fine. But then we have this thing for the insert comment. And I think what you wanted, Ed, was if mi8 equals 0, output all of that. And if it's not 0, run this post block here. We can do that, but in order to get 3 lines of output with this one condition being true, we have to group it. So what we're going to do here, we're going to do another set of brackets. And we make sure we do the close bracket as well. So if mi8 equals 0, we output all of this, else we output p insert comment. And we can do the same thing down here, which I think is what you were trying to do as well. So this else condition can get a set of brackets. So this one, and PBLD, and we need the close bracket here. So each one of these sets of brackets has to be paired together if you want it to be the result of one condition. So if mi8 equals 0, we're going to output all of that. Else, if it's not equal to 0, we're going to do p insert comment. Because that's the case here, we can just do else. So we'll do the else. All right. Now, this let me make sure I got it. I'm missing the close for this else. So what we need is one more close bracket. So this close bracket goes all the way to the top. This if condition goes all the way to the else. So that's all grouped. This if condition is single. This if condition is grouped before the else. If we go down to this else down here, this gets output no matter what if we hit the else. Then we have an if, which evaluates here, and the else. Now this is a situation, if mi8 equals 0, we're going to output 3 lines of code. Down here, if mi8 equals 0, we're going to output 3 lines of code. This is kind of the exact reason that a post block was, the idea of a post block came about, because we have 2 sections where the output of the code, if the result is true, is identical. So if we go back up here and look at this p insert comment, you can see out of holder, add notes, that's all going to be the same. It's just the insert that changes. So what we can do here, this is going to be the same. This is going to be the same in p insert comment. It's only this that changes if mi8 is 0. So what we can do is actually this. we can build all this into the p insert comment. Because if mi8 is 0, it's still the same condition. And we're going to output the insert, and then we're going to output out of holder and equals add notes. All from this output here. If you have unbracketed lines between if and else, no. The else condition must directly follow the if you're going to use it. But you can also do this. There's nothing that says you have to use an else. So here's a condition where mi8 could potentially have a ton of different values. 0, 1, 2, 3, 4, 5, 6, 7, right? And he wants different things to come out based on if mi8 is a different value. But if you wanted to use an else, it has to directly follow the if. So here we have an if else. Here we have an if else. Let's look through some more of this. Here we have an if, and the brackets make it. You can see that here, these brackets make it so that this else condition can directly follow this if. And that's why we have to group them with the brackets. Oh, that else is for the if up there. So this bracket here, and you can see that's why you have to be kind of careful. Oh, come on. That's why you have to be kind of careful when you are building your logic statements, because the if really does need to directly follow, or the else needs to directly follow your if. The else condition means essentially any other value. So if this is true, if the if condition is true, everything that's highlighted will get processed. Just because it gets processed doesn't mean it's going to output any data. Because as soon as we go into the bracketed post block here, we hit another if-else condition. If omit sequence equals 1 and T sequence number is greater than 0. So that is all of this data here. And if that is false, we hit this else clause. So if this is true, but this is false, we end up hitting this else condition and running everything that's in this set of brackets. But what we can end up doing is boiling all of these if-else's down to a single p insert comment call right here. Because p insert comment is going to read the value of mi8 and output our insert line. And then we have two additional lines that we want to output, and they're going to output at the end of this regardless. And basically, mi8 is always going to have a 0 value by default, unless you set another default value. Now, this reads the actual value of mi8 and chooses a different insert string to output based on the value of mi8. Typically, when we're building something like this, we use a string select table. And mi8 would be the selector, and then we would have a list of strings, 0 through, in our case, 51. Now, part of the reason it's not, I guess, as advantageous to build a string select table is because we would have to fill in each row. So if you want to go to a value that says 51, we would have to have 51 different string variables. So from 22 to 50, you notice we skipped a whole bunch in here we would at least have to have empty strings in our string select table. So this, for what we're doing, it does make some sense. Anyway, let's get back to fixing this thing. So we've got it to where we're outputting our tool comment. And the part that I missed was this right here. If home type is less than 2. This should actually be indented a little bit, because this, if not sync flag and tool op equals 67. So this code right here, you notice there's no else after that. So this is a separate if condition, and here is the else condition for that, which is what actually outputs the work offset, is this else condition right here. So basically we've got an if condition followed by another if condition. I had tried to output my comment from in here, so I had, I guess, gone down in here and said, you know, if s op com does not equal s blank, then pbld and $sign scom str sopcom scom end $sign. So if it's not blank, output it. But when we actually went to go post the code, we got our insert info, but we didn't get our operation comment. And we have op1 operation comment. So what I did was to run it through the debugger to try and find out why it wasn't outputting in the right spot. We do have a question. How many values can MI8 have? Something like 1 billion. So the miscellaneous integers on the left are integer values, and I shouldn't say 1 billion. I think it's actually something like 32,000. Depends on whether it's assigned as a long or a short variable value internally by Mastercam. Yeah, I typed in, you know, a bunch of 9s, and this probably set it to the maximum integer value, which is, no, it's like 2 billion something. But typically, practically, you probably could use up to thousands of numbers, but most of the time when you're, you know, picking something like this, you're going to have, you know, a more limited number, because for each number that you want to set in here, you're going to have to write code in the post to process it. Now, I see one of the things you're doing is picking up the type of insert from the post to get the data. And while we could do this with the insert number, there's probably a better way to go about that. So one of the things we can do, if we go and look at our tool, we're already assigning data in here, right? We got our insert name, CNMG 543. We got our IC diameter, so our inscribed circle. We got our thickness. We got our corner rad. We got our relief angle. All that data is here. We've already defined it. So why don't we have the post go grab it? We can do that with the inserts. We can do it with the holder information. We can grab any parameter you want from the dialog box here. Doesn't matter what it is, we can go get this information. So this data is stored in the form of parameters. When we're processing our post code, a lot of the stuff that we want to get into the NC file is given to us through the NCI data. This stuff isn't. Okay, a lot of this is it is setup information that's very useful to us, but it doesn't really impact the motion code, right? I mean, Mastercam, when it's writing its toolpath, yeah, it knows the shape of the insert it is using to generate the path, but the NCI data is the toolpath motion. That's, you know, the primary job of the NCI. You get some tool data output to the NCI file, but some of it is also output to the 20,000 series parameters. So let's revisit this when we come back and start talking about parameter reading, because I think there's some things that we could definitely improve upon and just make it easier. You know, I mean, why do extra work? That's my opinion. If there's a mechanism or a function in the post that'll let you go get the data, let's do it that way. So we still want to see what's up with not being able to output this code in the right spot. So what I ended up doing was running this program through the Mastercam debugger. Mastercam debugger, if we go back to the documentation, there's an MP debugger user guide. So I want you guys to read through this debugger document on your own, because I think you're going to pick up a lot of stuff. I'm going to go through this whole process fairly quickly because I want you to try it on your own. I don't want to sit here and spend an hour or two picking apart the debugger and, you know, going over everything before you have a chance to use it yourself. I want you to stumble around. I want you to try some things and, you know, I don't want to say struggle, but I want you to try some things and generate some questions, because then you'll be like, okay, well, I tried this. Why isn't this working? What's going on here? So keep that in mind. We're going to go over this fairly quickly. Most of the answers to the questions you could possibly have are contained in this document. It is pretty thorough, but you got to go through and read it. So what do we normally do when we debug? First thing we have to do is turn the debugger on. The debugger is turned on through the advanced configuration utility. So I go down to the Windows Start menu, Mastercam 2017. Advanced configuration. And that's going to bring up this dialog box. And under post support, post debugger, if it says disabled, you click on it. And when you click on it, it becomes a drop down. So the default is disable. Click it. Set it to enable. OK. And in Mastercam, when you select your operations and hit the G1 button, you now have this cute little button that looks like a ladybug that is the debugger. So I press the debug button. What Mastercam does is launches the posting process in a debugging editor. So you can think of this program, the post debugger, kind of as a program that manages the MPDLL process. I'm going to expand this. When we look at this by default, it's going to look something like this. You're going to have a bunch of windows in here and they're going to be all kind of slapped around wherever. First thing I normally do is go Window, Tile Horizontal. That's going to take all the windows that are open, and there's 6 of them kind of by default, and place them around the screen like this. Under Configuration, I think the default font is something crazy ridiculous like 7 point. So when you first open this up, everything is like tiny. It's super stupid hard to read. So go in here, Configuration, select Font, and I usually use like 12-point font. So after you do the font, Window, Tile Horizontal. The post window shows kind of a live in-memory version of your post processor. So one of the things you'll notice on the spacing when it initializes, so this is the actual post that's running right now. When it initializes this post, it adjusts the spacing a little bit. And it does this to kind of show you what's a post block, what starts in the first column, and what is indented. When I was zipping down through here to go look at the tool change, what I found was that in L tool change, we had this if not sync flag, and that was how it was bracketed. And then I saw this right here, if home type is less than 2. And then we have the else condition right here. So this is all one big if else condition, and I slapped my comment in here. So as I was processing, as soon as we hit this if condition, it just skipped down past it. I was like, okay, I need to separate this chunk of code from this chunk of code, which includes this if right here and this else down here. And if I put it in between, I'll be good to go. So that's what I figured out. I'll go do that now. So right here, I'm going to go debug, run turbo. Run turbo just runs the posting process till it's complete. It's the quickest way to run through the debugger. And when I go back to the debugger after my code has launched in the editor, this debugging session right now is actually finished running, and I can query the results. So I'll move the post over here like this. History, message log, don't really need those right now. So I'll take history, close it. Message error log, I'll close that. The key right now is going to be my NC output and the NCI. Okay, so as I look at my NC data here, we have the stream info. So we have the line number, the stream for a multi-stream op, NCI, so this is the actual NCI line number that created the output. Then we have the NC output. So you see NC output, and it gives us the actual line of code. Over to the right with the post block, we see where that output occurred from. So if I go up to the top, you notice the percent sign is from p header. When I double click the percent sign, it takes me to where the output started. So here's p header. You notice it calls p header custom. So p header custom had something to do with creating this output. Because I ran it in turbo mode, I don't get the full trace. And trace is very useful. I'll show you what that is in a minute. If I keep scrolling down here, you can see p header, p header, p header. All this stuff occurred from p header. Then there's a break after the M1, and I get this output from LSOF, lathe start a file. If I double click it, you can see that actually LSOF is where the output occurred, but it was actually this call to L tool change that generated this line of code. Well, in fact, the call to L tool change generated multiple lines of code. It generated this line, it generated this line, but we can't see any further because we ran it in turbo mode. So what I'll do, I'm going to go back in the post. I'm going to separate these two conditions because here's where I want my output. And I'm going to change this line of code and we'll put it here. And before I debug, so we'll debug again, but first I'm just going to test. So I'll take this set of operations, hit post button, and then I'll just post instead of debug. And now what we get is the tool command with the tool comment. We get our insert comment, and then we get our magic delayed operation comment. So we were able to successfully save the operation comment. Oh, it's actually up here. Now, one of the things we didn't do is we output the comment. Here it is. So we output the comment here, but every time we have a tool change, we're outputting the same comment again. So what we need to do is say, if it's not equal to S blank, we're going to output it, but then we're going to set it equal to S blank. We're going to erase it after we've output it so that we don't keep getting this saved operation comment occurring. Okay, so knowing where to output the data is important if you want to get it right. So here we've got this op1 operation comment, and then on the next tool change, we don't have that operation comment. Now, if we go and put an operation comment in op2, oh, that's op1. It's actually operation 2. Okay, lathe rough bore bar. Now, in our case, what we also want, right now, this is the location we're going to output the saved operation comment. It is also the place that we want our normal comment processing to dump the comments out. So I'm going to put the comment keyword here. This is only going to occur after the first round because we actually have comment up here in pheader. So the first operation, we've already processed all the comments, so that's why we can have it in two places without it causing an issue. Let me make sure that's saved. We'll post it. And if we scroll to the top, here's our operation 2 comment, and then down here lathe rough bore bar. So this was output by comment $ inside L tool change. This was output by the saved operation comment. All right, we're coming up on midway point of class anyway. It's a good time to take a break. So let's go ahead and split